So this turned out to be pretty straightforward and easy to do, to figure out the greatest common divisor and the least common multiple of two numbers when we have the prime factorization. It turns out that getting the prime factorization of numbers is non-trivial. It's actually very time-consuming, especially as the number grows and gets very large. And the fact that it is so difficult, it isn't difficult, it just takes a lot of computation time. And so because it is so computation intensive, it's actually used in encryption, in cryptography, because we haven't figured out an efficient way to get the prime factorizations of large numbers. So it's actually time prohibitive to use that. So straightforward as it is, it's not practical to use in the real world. So it turns out that a long time ago, a mathematician named Euclid figured out an algorithm that can compute this for us, the greatest common divisor. And this is that algorithm of how it works. And it turns out, and there's a theorem that talks about the greatest common divisor of x comma y is equal to the greatest common divisor of y mod x comma x. And the proof is in the textbook, so you can look through that and see how that works. What I want to do here is walk through this algorithm so you can see how this happens. Now, this is written in pseudocode. So it would be straightforward to implement it in a programming language because you can just follow it. So let's go ahead and work this out on paper. So here we have the greatest common divisor of 36 and 63 and the least common multiple of 36 and 63. Now Euclid's algorithm does the greatest common divisor, and then we'll use that mathematical equation that relates these two together to compute the least common multiple. So to do this, notice what values we're working with. We're working with x, y, and r. So those are the things we're going to track as we loop through this algorithm. So we'll do x, y, and r. And we start with, now if they're out of order, and I've done that on the second one, you want x to be the smallest. Right? And so that's the case. X is the smallest here. So we'll put it in. There's X. We'll put in Y, which is the 63, and we're set up to go. And we want to start, the next one is we need R. And so R is Y mod X. Now remember, that's the remainder. So if we divide 63 by 36, it's going to go in there one time. And what's the remainder going to be? It's 63 minus 36, and that's the remainder of 27. So that's 27. All right, so that's how we get it set up, is we get x and y in the right order, and we do that first initial mod. The next is, now we're going to go into this loop, and we'll stay in this loop as long as r is not equal to 0. We're going to keep going till there's no remainder. And so what do? We set y equal to x. So y becomes x, which is 36. X becomes the remainder. So x becomes 27. And then we do the mod again. So we take 37 mod 27. Well, 27 will go in there one time. What's the remainder? And the remainder is 36 minus 27, which is 9. Now, is r not equal to 0? That's right, it's not equal to 0, so we're going to keep going. And how do we do that? Y becomes x, and x becomes r, and we do the mod operation. So we do 27 mod 9. Well, 9 divides 27 evenly, goes in there 3 times, and the remainder is 0. So now we check the while loop. Is r not equal to 0? That's false because it is 0, so that's the end of the while. And what do we return? Notice what's returned. What's returned is what the current value of x is. So it turns out that 9 is the greatest common divisor. And if we go back and check, when we did it using prime factorization, we actually found that same number. Now, since we don't have the prime factorizations to use to figure the least common multiple, then we can use the formula, right? And do you remember what that formula is? It says the least common multiple is equal to x times y divided by the greatest common divisor. And so we have those values, right? We have x times y, which is 36 times 63, and then we can divide it by 9. So if we use our calculator to do that, and we do 36 times 63, and then we divide it by 9, and we come up with 252. So the same thing that we did last time. So we do the work to figure out the greatest common divisor, and then we simply plug in the formula to find out what the least common multiple is. All right, so now notice that we did the initial setup, and we went through the loop twice on these really small numbers.